Our topic of the discussion today is parabola. We will be identifying the different parts of the parabola, which are the vertex, the focus, the directrix, axis of symmetry, and endpoints of the latus, rectum, and so with the opening of the parabola. Let us define our parabola. This is a curve in which the locus of all points that are found on the curve has equal distance from a fixed point that is called the focus and a fixed line which is called the directrix. So if this is your parabola, this is what we call the focus. Now the focus will be determined as to where your opening of the parabola is. You can find your focus in there. Now, your directrix, this is our directrix, in which that is the line, a fixed line, which has an equal distance from, let's say, for example, this point here. This one has an equal distance on this fixed line, and so with this focus. Another part of our parabola is our vertex, which is the turning point of the parabola, and this would somehow determine the minimum point of the parabola and the maximum point of the parabola. Another one is these 2 points here are what we call as the endpoints of the latus rectum. So when we say endpoints of the latus rectum, these are the endpoints that are found in our latus rectum. So latus rectum is a line segment in which it passes through the focus. So wherever is the focus, you will be determining our endpoints in there, because again, when you say latus rectum, that is a line segment in which you will be passing, or it will be passing through our focus. And lastly, we have our axis of symmetry. So wherever is the focus and the vertex, your axis of symmetry, that is a line in which it passes through our focus, and so with the vertex. And it also divides our parabola into 2 identical parts and equal parts. So they could be considered as symmetrical. Now let us now go to the orientations of the parabola. So there are 4 orientations of the parabola that would somehow be dependent as to what is the variable being squared. If you've got an x which is being squared in an equation, so automatically we will be viewing our parabola as opening upward or downward. So let's say here, this is upward parabola, this one is downward parabola. And most likely, our equation for that one is x squared, that's equal to, so you've got x squared equal to positive 4ay if your vertex is at the origin. So if your vertex is here, that will be our equation of the parabola. But if your vertex is not on the origin, you will have your equation as x minus h, and then we square that one. That's equal to 4a times y minus k. The downward orientation of the parabola, it has an equation which is, again, our squared variable is x, and that will be equal to a negative 4ay if our vertex is at the origin, if our vertex is here. Now, if the vertex is not the origin, our equation will be x minus h squared, that's equal to negative 4a times y minus k. So next orientation, so we have here sideways. So if your parabola is sideways, our variable that is being squared is our y. So let's say if our parabola is on or opening to the right side, and then we've got an origin which is our vertex, your equation will be this one. So we have a squared y that's equal to positive 4ay, because our direction here is to the right, and to the right of your x-axis are positive numbers. So that should be positive 4ax. And if your if your vertex is not at the origin, rather than other numbers here, so let's say here, your equation or the standard equation of the parabola will be y minus k and then squared. That's equal to 4a times x minus h. Now, if you've got a left side orientation, so your opening of the parabola is opening to the left side of your x, and most of the numbers on the left side of the x axis are all negative. So your equation, the standard equation, if you've got an origin as the vertex, is gonna be y squared equal to negative 4ax. And then if the vertex is not the origin, so you will have y minus k and then squared, that's equal to negative 4a and times x minus h. So those are our different orientations of the parabola and their standard equation or the vertex form of the parabola. Next one, let's now try to identify the different parts given an equation of the parabola. So let's say we have x squared equal to 4y. So once we say x squared, our x is being squared. So our orientation of the parabola is going to be either upward or downward. But if you try to look at the one beside y, you've got a positive number in there. Take note, positive numbers on your y-axis are upward. So that should be upward orientation. Or you can have it as up. Next, vertex. So once we are going to look for the vertex, we must ask ourselves like this. Do we have an x which is, or do we have a number which is added or subtracted to your x? So the answer there is none. So that means this is 0. On your y, do we have a number added or subtracted on y? So since we don't have, so that is 0. So the vertex now is at the origin. So plotting that one here, this is our vertex. Now next one, let's go to the focus. For the focus, you are going to be dependent on the a of your equation. So notice on our standard equation or the vertex form equation of the parabola, we have that one as x squared equal to 4ay whenever that is upward. So meaning to say, we've got an x squared here, we've got an equal sign here, and then we've got a 4 here and y. So we have a y here, so automatically this number 4 here is our 4a. So once we have 4a is 4, we are to look for a because your focus there, if we are to talk about the properties of our parabola, the focus has a distance from the vertex which is equal to a. Again, the distance between focus and the vertex is equivalent to a. So we will be looking for a once we are going to look for our focus. So we divide this one by 4 and so with this one so that we can come up with an a which is equal to 1. So our a is 1. Now, using the graphical method in which we are to identify the focus point, we are to simply count the number of units equivalent to our a. Since a is 1, so we are going to count 1 unit. Now for focus, take note that your focus, the location of the focus with respect to the vertex, it should be in line with the opening of the parabola. So since that's upward, automatically the focus there must be located at the top of our vertex. So we will be counting from the vertex 1 unit up, and that will be our focus. So counting off, we have from the vertex, that is 1. So this is now our focus. So naming our coordinate of the focus, we have that one as your x here. Our x here is 0. So that should be 0. And then we look at y. Our y here is 1. So our coordinate for the focus is 0, 1. Now next, directrix. Take note, whenever we say directrix and focus, they always have equal distance from the vertex. So we need to say, if vertex and focus, the distance between those two is a, vertex and directrix, the distance between the two is also a. So automatically, once we are going to look for the directrix, we go counting of the number of units from the vertex to the opposite side. So since A is 1, so we will be counting off from the vertex down 1 unit. So this should be our location for the directrix. But take note, when we say directrix, we are going to draw a line for that one passing through that particular unit, the 1 unit from the vertex there. So this will be our directrix. Now, since that is a line, we are going to identify the equation of the line when we say directrix. So how do we identify the equation of the line? Now, we must make sure that we know where our line cuts through. So this one is passing through your axis, which is y. So that should be y here. And then we must ask, what is the value in which that directrix is passing through our y? That is equal to -1. So that should be y equal to -1. So next one, we have to draw the axis of symmetry. Axis of symmetry will always be passing through a line passing through focus and a vertex. So that should be here. So our y-axis is our line of symmetry. So automatically, we are going to identify our equation since that's a line. Axis of symmetry is a line. Now, the line here, if you try to look at that one, that's identical to the y-axis, but that doesn't mean that we really have to take the y-axis all the times whenever we say parabola as our axis of symmetry, because again, that will be dependent on where your focus and vertex lies. Now, how do we identify the equation of the axis of symmetry? We are going to ask ourselves, as to this line here, which axis is it cutting through or passing through? Now, since this one is on the y-axis, it passes through, the line passes through our x-axis, or it cuts through our x-axis. So that is why we have here x equal to, and again, we are going to determine what value of x are we cutting through. We are cutting through the vertex here, and the vertex is 0, 0. So automatically, this is 0. So next one, we are going to identify the endpoints of the latus rectum so that we can draw the graph. So the latus rectum here, this should be, okay, the latus rectum in here, or the endpoints of the latus rectum, will be determined through multiplying our a by 2. So 2a, that's equal to 2 times, our a there is 1. So this is equal now to 2. So counting off from the focus 2 units to the right and left, because again, when you say latus rectum, that's a line segment passing through the focus. So it's gonna be left and right, because if you are going to go for up and down, you have there the vertex. So it must not be with the vertex. So we are going to count 2 units to the left. So we have 1, 2, and 2 units to the right. So we have 1, 2. So these are our endpoints of the latus rectum. So naming the endpoints of the latus rectum, so we are having here, this one is with -2, and then our y value here is 1. And you have another point which is with this one here, our x is 2, and then our y is 1. So those are our endpoints of the latus rectum. Now, next one. What is the length of the latus rectum? So the length of the latus rectum is this one here. So from this endpoint to that endpoint. Now, under the properties of the parabola, from the focus to an endpoint of the latus rectum, that is always going to be 2a. So this one from the focus to this endpoint, again, that's another 2a. Adding those two, that will be 4a. So we are going to multiply our 4 to our a, which is 1. So we have 4 times 1, that's equal to 4. Or simply saying, whatever is here beside or multiplied to your y, that will always be our length of the latus rectum. Get the absolute value of that one, and that is our latus rectum. So drawing now our graph, so we just have to connect this endpoint here to our vertex. So we are going to draw a curve here, passing through the endpoints, and then draw an arrow on that one. So this is our parabola. So next example, we have x squared equal to -8y. So again, we have the opening opening of that one, since we have x squared here, that's also going to be up or down. Negative 8 is here, so that should be downward. Because when you have up or down parabola, once your opening is downward, it should be on the negative numbers of your y. So that should be negative 8. So that's downward. Next one, we go for the vertex. Since we don't have a number added to or subtracted to your x, so automatic we have a 0. And at the same time on y, we don't have a number added or subtracted, so that's also another 0. So our vertex is at the origin again. So next one, we go for the focus. So again, in determining the focus, we must identify first our A. So we have this one as our 4A. So 4A is equal to negative 8. And take note, this is downward. So our equation there must be a negative 4A. So we divide this by negative 4. And so with this one, so our A is 2. So meaning to say, from the vertex here, since this is downward, we move down 2 units because your A is 2. So moving down, we have 1, 2. So this is where our focus. So next one, we are going to identify the coordinate of the focus. Our x here is 0. And then our y is negative 2. So next one, we go for the directrix. And again, the focus. And from the focus to the vertex, we have the same distance of that one from the vertex to our directrix. So if we're counting here 2 units down for the focus, we count 2 units up for the directrix. So we have 1, 2. So from here, we are going to draw a line because directrix is again a line. So we are now formulating our equation. So for this one, it cuts through our y-axis, so that should be y equal to the value of your y-axis is 2. So next one is axis of symmetry. So from the vertex and focus, we are going to pass through. The line will pass through those 2 points. And then that will be our axis of symmetry. So since this is a line, we are going to formulate the equation. Our line there passes through the x-axis or cuts through x-axis, which is equal to 0. So that should be our axis of symmetry. Next one, we are going to write down the endpoints of the latus rectum. So we are going to count the number of units from the focus to that particular endpoint, and that will be based on our A here. All the time, so when we say endpoints of the latus rectum, we always have that one as, from the focus, we have that one as 2A. As the distance. So from A, we have our A as 2. So we have 2 times 2. That's equal to 4. So we will be counting 4 units from the focus to the right and to the left. So we have 1, 2, 3, 4. So this is our endpoint. And then from the focus to the right, 1, 2, 3, 4. So this is our endpoint. So naming the endpoint here, we have that one as our x here is negative 4. And then we have our y is negative 2. And another one, which is here, we've got that one as 4. And then we have our y, which is negative 2. So next one, we go for the length of the latus rectum. So we have that one as 4a. That's equal to 4 times our A is 2, that's equal to 8. So again, your length of the latus rectum, you just get the absolute value of this number multiplied to your y. And then drawing our parabola, so from the vertex to the endpoints, we are just going to connect that one. Oopsie. And also with this one here. And that will be our parabola. Here we have y squared equal to 8y. So once we have that one, so again, this is x by the way. So we have 8x, sorry on that one. And then once we have that one, our y is being squared again. So our orientation is sideways. So once we are going to look for the opening of the parabola, we base that one on the sideways and the sign of this one. This is positive, so that should be to the right. Next one, we are going to identify the vertex, since again we don't have a number added to y, subtracted to y, so that should be on y here is a 0. On x, we don't have a number added or subtracted, so that should be also a 0. So vertex is at 0, 0. Now, next one on the focus, we always find our A. So based on this one, this should be our A. I mean, not A, but the 4A. So 4A is equal to 8. So divide that 1 by 4. And so with this one, our A is 2. So since A is 2, we are going to count the number of units. Since this is to the right, the number of units to the right from the vertex to 2 units. So we have 1, 2. So this should be our focus. And then identifying the coordinate of the focus, we have that one as our x here is 2, our y is a 0. Next, our directrix. So if we've counted to the right on your focus 2 units, we will be counting to the left 2 units also for the directrix. So we have 1, 2. So this is where we draw our line. And so with that one. Okay, next one, we are going to write our equation for that line. So the line there passes through our x-axis, so that should be x equal to, and then it passes through the value negative 2. So next one, axis of symmetry. So where your focus and vertex is, you are going to connect that one with a line, and then our line there, we are going to find our equation. So since that line is identical to the x-axis here, so automatically the x-axis cuts through with the y-axis. So that should be y equal to, that is equal to 0. Next one, we go for the endpoints of latus rectum. We are to multiply our a with 2. So we have 2a, that's equal to 2 times 2, that's equal to 4. So we will be counting from the vertex up and down 4 units. So we have 1, 2, 3, and then 4. And then down we have 1, 2, 3, and then 4. So our endpoints there of the latus rectum has a coordinate which is, from the top we have 2 on your x, and then we have on the y which is 4. And another one we have on your x, we have 2 still, and then on y is negative 4. So next one, we go for our length of the latus rectum. Length of the latus rectum, we just have to multiply a with 4, and that's equal to 4 times 2, which is equal to 8. Or simply our number here, that is our length of the latus rectum. So drawing now our parabola, since that is to the right, so we connect our endpoints and then the vertex. And then the vertex, connecting that one to our endpoint, and then draw an arrow. So that is our parabola. Once again, this is your teacher Jenny saying thanks for watching, and please subscribe and like this video.